Okay, so hello, this is Johnny, and this is question 15 from page 82 the PM1 book. So I'm going to help you to solve this question. So, question 15, the equations of two sides of triangle ABC are x plus 2y equals 8 and 2x plus y equals 1. Given that A is the point 2 and minus 3 and the triangle AB and the angle ABC is 90 degrees, find the equation of the third side and the coordinates of point B. So let's try the part A first. Now when you first read this question, it can seem a little complicated because we're given a lot of content, a lot of ideas, but they are not connected, so we have to find a way to connect them. So the first idea might be to sketch this triangle, because you know the equation of two sides already, right? You only need to find the equation of the third side. So you know this is a right triangle and the right triangle is at B. So maybe you can draw something roughly looks like this. Here, you know this is B, you know this is A, and you know this is C. Now you don't know which side these equations belong, so we have to do some trial and errors here. So let's firstly, to make it less complicated, let's rewrite them in a y equals mx plus c way, like this and like this. So you've got two equations, right? So now from this, the first thing you may notice is that the gradient of this is minus 1/2 and the gradient of this is minus 2, which means that these two lines are not perpendicular, because if they were perpendicular, if this was minus 1/2, the other one should be positive 2, or if this one was minus 2, then the other one should be positive 1/2. But this is not true, right? So we know that right from the start, this scenario of this equation and this equation being here is not true, because they are not perpendicular to each other like that. So we scrap that idea. So we have two cases left. It would be one equation being this line, and this equation being this line, or the second case, which is, let me draw this again, one equation being this line and the other equation being that line. So now we have to decide which scenario is this actually, right? So we can use the method of equating the two equations to find intersection, because they can either intersect at point A here, or point C, right? And we already know the coordinates of A is 2 and minus 3, which means if we equate the two equations and we get a different answer, then we know that should be the x coordinate of C, or if we get 2, then that should be the coordinate of A, and that also means that they cut in this order. These are the two equations belong to these lines. Other case, they will belong to these lines. So let's try to equate the two lines. Now we can see why this is useful that we arrange them in a y equals mx plus c way, because now we can easily just equate these two expressions together. So we get 4 minus half x equals to 1 minus 2x, which we can solve easily by bringing the numbers and the x's to the same side. So we get this 1 minus 4. So from this we can get 1.5x equals to minus 3, which we can get x as minus 2, right? So as we can see, the value of x is minus 2, which is not 2 of the A. So we know that this should be the coordinate of C, and therefore this should be the correct triangle. So we can put minus 2 here. Then aside from this, we can also find the y value of C, right? Which does not answer the two questions, but it can be a very useful tool, or a very useful piece of information that we can use to solve the question. So let's find y. So y is equals 1 minus 2 positive 2, which is 1 plus 4, which is 5. So we know that C is minus 2 and 5, like that. So now we only got to know that the triangle is arranged in this order, with these two sides being the sides of the equations. So now we still don't know yet if this is 4 minus half x, or this is minus 4 minus half x, right? So one way to determine this is to find the gradient of the line A to C, because we have the coordinates of A and C already, right? So we can find the gradient of A to C, and if it is minus 2, it should be this line. If the gradient is minus half, it should be this line, right? So let's try that. The gradient of AC is different in y over different in x. So we got minus 8 over 4, which gives us minus 2. So we know that this line right here, should be the equation 1 minus 2x, and this line should be the equation 4 minus half x. Okay, so we know equation of two lines already. Now with this piece of information, we can easily find the equation of the third line, because we know that the third line AB is perpendicular to the line BC right here, and we know which equation belongs to BC. Therefore, from this equation, we can determine the equation of this last line. So firstly, let's find the gradient, right? We know that the gradient here is 1 over 2. So the perpendicular gradient should be minus 1 divided by minus half, which gives us positive 2. Now we have the equation y equals 2x plus c, and we have to find x, right? And in order to find x, we can substitute x and y. And in this case, we can substitute the coordinates of A into it, because A also is a point on this line, AB. So then we can get minus 3 equals to 2 times 2 plus c. And we can easily solve for c equals to 7, which solves the first question. So first question is the equation of the third line is y equals to positive 2x minus 7. That's the first answer, and we can also write that here, 2x minus 7. Okay, so that's the first question. The second question asks for the coordinates of point B, which is this point right here. Now, since we have the equation of AB and BC already, this turns out to be a very simple task, right? Because we just need to equate the two equations of these two lines since they intersect at point B. So very simply, we can just write 2x minus 7 equals to 4 minus half x, which gives us 2.5x equals to 11, which gives us x equals to 4.4. And with this value of x, we can find the y as well. So 2 times 4.4 minus 7 equals y, 8.8 minus 7, which gives us y equals to 1.8. So the answer for part B, the coordinates of B are 4.4 and 1.8. Very simple. So that's how we solve this question 15 on page 82. We have to use some concepts in gradient and intersection to determine which equations belong to which line here. Therefore, we can find the perpendicular line of the one of the equation, which gives us the AB. And once we know AB, we can easily know that it's the intersection between AB and BC, which helps us use the idea of equating to find the coordinates of B. And this is our answer for this question. Thank you for watching. Bye.